made sense, didn't it? Sir?
Did we turn in the homework from Thursday?
Did we?
Wednesday?
Probably not.
Yeah, that's right, because I did punch me.
You guys had time to go punishing in class. We didn't have to.
Yeah. We, like I said, we went over a bunch of those problems, and then I showed everybody how to do the word problems on the calculator. So it's all about vector stuff. I can get you guys caught back up later in Flex if you want. It doesn't take long. So exponential functions. I should have been here to start with. They're all off track. Remember, exponential functions were these. Y equals AB to the x. So what we're going to do, we're going to write the function out. We're going to write the function out, given a set of ordered pairs. And then we'll talk about how we work with it, with the graphic. It is a 24. When I did that little snap picture to bring it in, it put a little line in it. So the ordered pairs are 1, 6, and 3 and 24. So I apologize. You know how those little cursors get in the way sometimes? That's all it was. So when we do these, just like we have in the past, when we're going to write out equations, a lot of times you wind up setting up a system. So I want you guys to substitute in for x and y for both those ordered pairs and create two equations. Here's what happens. We wind up with 6 equals ab to the first power, and 24 equals ab to the third power. You okay with that? Now, unlike some of the other systems of equations that we've done where we had to do elimination and things like that, where they were more linear, if you will, where the 3 variables and 2 variable things, what I'm going to do here is just go direct substitution. I'm going to get a by itself in that first equation. You okay with that? And it's usually a that you're going to deal with because a doesn't have an exponent to worry about. So what happens then is that you know that a is going to equal 6 divided by b. Where are that? And substitute in the other side. You all right, man? All right. No big deal, just wondering. So you wind up with then 24 equals 6 divided by b times b cubed. And this is going to allow you to lose a degree in the b. Because what's b cubed divided by b? So you got a b there. I had a weekend to think of more jokes. Never said I was that one. Look at that. About it. So what do you do to solve for b?
You know, divide by 6, and then it's the do square root, and then it's 2.
It's plus or minus 2.
Well, when you're dealing with exponentials, your b value is always positive. I don't know if you guys remember that. So it's okay in this case, you don't have to worry about it because your b value is going to be positive.
And then a is 3.
Yeah, because we're working with the exponentials. No, because it was the a value, wasn't the a that designated the direction, but it was the b value was always positive.
Sure.
The a, because the a was between 0 and 1, the other one was between greater than 1.
Are you asking or are you talking?
Yeah.
If it's less than 1 minute.
I'd have to go back and double check it. But in our case here, b's for what we're doing now, it's going to be positive.
Okay.
All right. So now you figured out what your b value is. What do you do to find a?
You plug it in.
Back in.
You go back here again.
Yeah, now
So a is 6 over 2, which is 3. That means your function that goes through these two ordered pairs, y equals ab to the x, would be 3 times 2 to the x.
6 to the x.
No, remember when we have these, we keep the that b value has the exponent. And that's it. No, remember the secondary term is the one that has the exponent, raised to the exponent. It's a times b to the x. And I really, really, really think next year when we do all this modeling stuff, I think it's going to make a lot more sense to keep it within the same realm of the problem of that chapter. I think it'd be cleaner, even though it is kind of nice to bring them all together at once. But a lot of words. Yes, ma'am. No. For the
Seventh grade.
third time, no. Okay. Let's do another one. You guys do this one.
It's like 3, 2,
Seriously.
1.
Sorry, guys. Just laugh. Come on.
I have no 30.
All right, let's see how we did.
1/4.
No, you're not making the one.
Yes, ma'am. Not necessarily. I can show an example here in a little while that it isn't that, but then you need to start using those exponents when you substitute over.
36, not 26. I don't know why I wrote that.
Did you get 12 for B? Yeah. Yay! And then you get 1/4 for A? Yay! And there's your equation. And no, I cannot simplify as equal 3 to the x.
Are you sure?
I am positive.
Okay. Hey, it's Tuna. Is that Tuna? You were right about Kentucky losing.
That's a wild one.
Which one? The goofball standing up? Yes.
He likes to argue too much.
He does, but he's good at it. He's pretty good at it.
But he also loses.
Oh, are you talking about, is that the whole Kentucky thing you're talking about?
I told him that
That's exactly what he just said. Just walk by and
Are you trying to get shot?
don't mess with Tuna. What's up, Tuna?
At least everyone would. And then his brother, like, he said his brother.
Alright. Let's look at the weird stuff.
He is real.
Let's look at the weird stuff. So, what I want to do here real quick is show you guys how you can identify exponential models when you're dealing with a table. Now, it's kind of difficult to know if whether or not it's going to fit an exponential model versus a power model. When we get into the exponential models, when you put this stuff into the calculator, let's do this into your L1 and L2, and let's create the scatter plot real quick. Okay? We'll do an L1, L2 scatter plot. And we'll call the first top one L1. This will be our L2. I have to load mine at the same time here. I'll move it, no worries.
And also, I might have to be able to do this thing the day after my mom's going to ride, like an hour away after your
That sounds like a person.
Even though, like, you guys are lying, you never range your room toward where it's at. I was gonna say, like, why would you do that?
Because of Wikipedia.
Oh, it was 10.
I don't have like a.
40 48.7 was the last one.
I'm looking up actors because like I'm like, no, but
Okay. All right, so what we've done here, guys, I want to make sure you guys all understand how to get your windows and stuff set up here. If you look at your data, we're plotting L1 versus L2. We're saying our X values are going to be 1 through 10, and then our Y value is going to be the other stuff. So change your windows. Go to your window value, and our X minimum, I have it set at 0, my X maximum is 10, that's fine. When I do my Y minimums and Y maximum, it's all first quadrant, so might as well make your Y minimum 0. And our maximum Y value, I'd say, what would you put it at? 50. Perfect. That's what I would do. Now, you can't just hit graph because you got to go to your second stat plot. So you have to turn that one on to make sure that that's what you want to plot. Okay? Second Y equals. Okay? Now, if you hit enter, it should.
Yeah, so whenever A is
Alright, so this is showing that it's increasing up. But we don't know if it's an actual exponential function yet. In order to tell if it is going to be an exponential function, the trick is to show it what I want you to do is take the natural log of your L2. Now your calculator isn't just going to do that. So what you have to do is take the natural log of those.
So we can add them together.
No, each individual one. So what happens here is I'm going to take the natural log of 1.6. Natural log 1.6, hit enter. 0.47. Okay? What's going to happen here, what happens here is if this is going to be a true exponential function, let me go back to our graph here. If this is a true exponential function, I'll show you what. Some of you guys do this half.
0.99 is 2.71. 1.48.
Somebody start on the 10 and work our way inward.
I'm 1.48.
Wait, what's 3?
1.48.
48.7 is 3.89.
10 is 3.89. 4.
13.1 is 2.57.
Ah!
That kind of scared me.
6 is what?
2.57. 9 is 3.64.
How about you guys do this?
4 is 1.86.
8 is 3.1.
Yeah, 8 is 3.4.
This is like rapid fire badness here.
Wait, I want this one.
2.96.
2.96.
2 for the game.
Thanks, Jared. Appreciate your help.
I gotcha.
So now I want you to overwrite. Well, actually, you know what? Let's make another list. Let's make another L. In your calculator, yeah, let's make an L3. Sure, why not? We're going to edit. We're going to go to L3. You know what? I wonder if this would work.
How are you standing
You just put like the natural one.
So in your calculator, you can, instead of doing all that by hand right off the bat, you can just go natural log 2.7,
Wow.
natural log
Oh,
4.4.
Oh, is it?
Well, I didn't know. Come on, I was. Well,
The next time you better know.
Mr. Murray is
I didn't know it did that. That's kind of cool.
Dude, this dude's the wires. He's been standing the whole time.
Doesn't matter. He needs to stand. He needs to stand.
It's
Maybe he thinks better standing up.
one leg on the chair.
That's pretty gnarly.
Did you just say gnarly? Okay, so now you have an L1 versus L3. So what I want to do here is I'm going to do a stat plot again. So we hit second y equals, and we have to go into here and adjust our L1 and L2. So I want to plot change my y list to L3. I'm guessing if we hit enter, which button? I can't see it on this one. There should be a blue button. Pick number 3. If you hit 3 here, it should pop up.
Oh, there you go.
Oh, that didn't work.
Second L3.
Oh,
Second, three is over.
there we go. Hit second 3, because then it comes up for the third list.
Second 3. Wait.
Now, with any luck, it should work.
I didn't even get that last one.
I have a feeling that I might have done screwed up with value in my table.
I don't know what they're talking about. That's
After you're done, there's arrows here.
Oh, I just typed, I grabbed the natural logs. There's a problem. All right, we'll try that again. Now, what I want to do here is I'm going to adjust my y maximum again. Adjust my window. I'm only going to leave my window at 0, but what's the y value I should go up to? Let's go to 4. And I want you to see what happens now. What does it look like?
The other graph.
It looks like a line, doesn't it? It looks linear. It looks linear. What happens is, in order to tell from a table if it is truly an exponential model, is that the natural log of your y values, when you plot it against your x, should be really, really close to linear. It should look like a straight line. It should look like a line. Okay? That's pretty darn close. That's how you're able to tell from looking at a table set of values. In order to tell if it's an exponential function, you plot x versus the natural log of y. If linear-ish, then it's exponential. Yes, ma'am. It is not doing whatever I'm doing? What is it doing?
That's just like a lot of calculator work. There was like.
Okay, so if we do create a graph, there's an X, and then there's
To show exponential functions, you have to plot the x versus linear graph, and natural log of y.
Go to MIT. Yeah, why? I don't know, just go to MIT. Yeah.
Oh, yeah.
It's like
So this is your
I lose sight of
Oh gosh, that one guy. Did you want to start
Because if I check
That would be, that would be so awful. That is
So we went over to talk to them and like
So, I'm not done. I'm almost done. What? I know. So, did this look linear-ish?
Sure did.
Yes. So, that means we have to go back to this graph and write the equation. The calculator will do that for you. You just have to select the correct values. Remember, we're doing exponential regression now. So if we go back to here, stat, calculate.
So did I.
Where's the F code?
It's zero.
0.
I thought we were done.
So this defaults back to your two lists that you had, your X, or your L1 and L2, which is what you wanted to do.
Which one do we just to get there?
Oh, hit stat,
Stat, calculate zero.
then you want to hit calculate,
Zero.
and then it's option 0, which I think if I just go up, it'll probably be quicker.
you can just press zero.
Or you can press 0. Is that what you got?
Like zero.
Oh, no. So my calculator defaults itself back to L1, L2. I think yours doesn't give you the option to do that, but it should just come right out. So if I hit enter, and there's your equation. Yes, sir. What's that? Magic. What you're doing here is you're hit, since you found out by looking at the table that it does look linear-ish, that means I can go back to my original data to get the equation of that best fit line. So my best fit is that with my A and B, which means I can use that then to answer the last bit of the question. This is not difficult to do whatsoever. It just takes time to check everything out in the calculator. That's all.
So will there not be like a ton of these problems on like the test?
Maybe one.
So we get a
Yeah, that's enough, maybe.
So will we get a calculator? No, you gotta crank these out by hand. Yes, ma'am. I usually go 2. So if you guys take this equation here where it's 1.3, and then the next one I have to say B would be 1.46. That's what I would round that out when I'm putting it in my calculator to get my model. Okay?
Always go to the hundred.
Yeah. 2 is a pretty decent spot to go with.
What if
Because-
what if it was like 0.000 then numbers, would you go until like the second?
Like that? No.
I would just go to the hundreds.
So it would be zero?
Oh, if I said, okay.
So it'd be like 0.000.
Yeah, I see.
3.
Yeah, I see what you're saying. Yeah, then use your best judgment. How's that?
Or you.
Because if you use scientific notation,
Don't tell I think it's C.
well, all right. There's nothing wrong with scientific notation. I just don't remember how to use it. So I'm calling myself.
So if you just say you don't know how to check it, so it's just right. You sound smart.
No, it's because I haven't used scientific notation in. A long, long time ago, in a galaxy far, far away.
I'm never gonna use chemistry ever.
I'm not going to become a chemist. I'm not gonna. I'm never gonna be a chemist. I would probably kill this.
Yes.
How many of them?
No. 6 of them.
How about like for every?
This is exciting. Once again, I want you to verify that this is an exponential model. In order to verify that it's an exponential model, you have to show your natural logs. It's not difficult work. Because you just plot them through because you want to see the curve. Because you have to go back to the original in order to get the regression. Okay.
You have to look at the curve, and you don't have to prove that there's a curve.
Well, we know that there's gonna be something there, but sometimes the data set, as soon as you look at the curve, if it looks like it might be exponential, but sometimes exponential ones look like half of a quadratic also. So it's one of those things you just have to be, that's why we know
You
that.
assume that if you put in the L2 and then you quick look at it, and if it's like all curvy, it's not.
Yes, you know that, but unless you were like me and you typed in the wrong thing twice,
Oh.
and then you have to double check the data. It's not, like I said, you're just falling all over the place, aren't you? It's not a difficult concept at all. It is pure calculator.
It's difficult for me.
Obviously, everything's difficult for your. I just sit on the floor, it'd probably be safer.
No, I'd probably bang my head on the desk still.
All right.
Oh, it's not?
So when you say to show your natural laws, do you mean to write down?
Just do a quick look. I mean, I know what you're saying there, Ben. When we do this on the like a test or a quiz, I'd like you to fill it in. Like, I would give you a table like this,
Okay.
then you just make a little box below it, type of deal.
All right, yeah, that makes sense. This is shared here, yes.
Yeah, it's pretty straight.
Who wins?
Nobody.
No, sponsor grant doesn't do it. You choose if you're a sponsor grant, you choose to try out. You don't have to.
So you said
Right, the national expenditure.
Yeah,
It's maybe British.
It's linear.
because that's showing that you're doing it. You know what I mean?
But is that linear?
Yes.
Would you like, but like there's those two over there that kind of pump up really strangely. You could argue that that's like a change.
No.
I'm so happy we've not.
You're not learning. You're not speaking English very well either. What?
Oh. Emma.
Because some people don't be
If it doesn't look linear, is that
If it doesn't look linear, then it's going to be something else. We'll worry about that as we get there. What's that? Check your window. Remember, you guys, you'll have to readjust your window on this. Ladies and gentlemen, come on. Izzy, what do you got?
Mine doesn't look like that. Mine
Yeah.
is going right.
Well, let me check here.
It's not
Well, for the first one, I made it 305. For the
What's that?
how to change it.
Oh, okay. Remember, to change your graph, go to L1, L3, you hit second stat plot, hit enter. Did you hit second stat plot? Oh, no. Second stat plot is up here. So then you change it to L, or your Y list to be L3, so then you get second number 3.
See, the reason why, like, part of the reason why
Then you have to change your window again.
why I have thin frame like that is because I don't look good in
Did you get something that looked linear? Okay, so then you had to go, well, you have to keep readjusting your windows.
475.
Well, your smallest value here is 0.47, so put in zeros, right, then you go up to 4
Also,
for your Y values. X values, you're at 0 to 10.
Yeah.
like, in context,
And then it's just a matter of going back to the regression. So let me give you a couple of these to try out for tonight.
English is not. It is not my favorite.
How much do you
I have 3 weeks. Oh my god. You should complete
Okay?
You don't know what's up.
No!
volunteer. Almost. I have been in New York all weekend. I didn't see me on the phone. Oh, no, that's because you're late, weren't you? Yes, we were, and I bet you had your internet with you too. No, that's kind of like really arrogant.
No, it's not. It's just broke because.
It is true. Wait, are we on the meeting with internet? It's almost today?
Probably not. I think we're not.
Yeah, no, Destiny.
Oh, you turn it on.
No one told me about this. I had no idea.
All right. These are all, they're all back up online. You just have to click on the right tab. Yes, ma'am. When you do the two graphs, to go back to the equation, what you're going to do is use your exponential regression in your calculator. If you hit stat, calculate, it's option 0. It'll be exponential regression. And then you're going to select it to come out of L1 and L2, because that was your original two values. Okay? Yes, ma'am? I don't know. It depends on how far we get through, because we have 8-7 here. I want to do logistic growth problems tomorrow, and then we have to do the sinusoidal ones, the trigonometry ones.
So nothing till next week?
I don't know. It's going to be close.
Oh, there's so much on Friday.
All right? It'll be close.